Hello, everyone. Welcome. I'm Carol Willis. I'm the founder and director of the Skyscraper Museum, and many of you who have joined us regularly on our virtual book talks or on the web to hear them after they've concluded. We're very pleased to have the celebration of this book, Shigeru Ban Timber in Architecture, that brings together projects that span about 20 years that explore in the extraordinarily aesthetic and innovative way the possibilities of the material of wood. Early on, Shigeru Ban has been interested in materials that are both traditional, but in using them in new ways. And certainly many of you know his paper architecture, and a book preceded this one on timber on paper architecture or paper in architecture, where rolls of paper have been the material of creation, often for temporary shelters in a disaster relief effort, where the system of building very quickly from a system of parts is something that Shigeru Ban has been able to deploy in a humanitarian effort. So from that work and to the extraordinarily beautiful, as you will see today in the slide lecture that Laura Britton is going to give us to represent the firm's work, you see the kinds of material that earned Shigeru Ban the Pritzker Prize, the kind of Nobel Prize of Architecture, about 10 years ago, actually, in 2014. So now I'm going to, very shortly, I'm going to introduce Laura Britton, and I'm sorry to say that Dean Maltz, who is like Laura in the New York office, Shigeru Ban Architects has offices in Tokyo, in Paris, and in New York. And Laura is based here, as is Dean Maltz, who is a managing partner and was a student along with Shigeru at Cooper Union some decades ago. Dean was not able at the last minute to be with us tonight, so Laura is going to do kind of both parts and present about 40 minutes or so of a beautiful spectrum of the work in extraordinary photography, and will explain both the conception and process of building in wood. So Laura is an associate at Shigeru Ban Architects, and she's also an adjunct professor and assistant professor at Cooper Union, where in fact she's teaching a studio on mass timber. And she works especially in the area of mass timber, and she is the author and editor of this compilation, the monograph that collects the mass timber projects and the timber projects of the firm. As I said, this is work that spans almost 20 years. And while this mass timber is a modern material, it's obviously also an ancient material, and especially in the Japanese tradition. And I know Laura is going to share some of that. So Laura is an architect working in the firm, and here she is. She is educated in architecture first at Yale and then at Princeton. So she has been kind of gathering this material and living this material both in practice and in a kind of production of a picture of the work of the firm. So Laura, I'm going to leave you now and hand you over to have the screen.
Great. Thank you so much, Carol. Hi, everyone. I'm Laura Britton. I'm an associate at Shigeru Ban Architects and the author-editor of Shigeru Ban Timber and Architecture. As Carol mentioned, Dean Maltz, our managing partner in the New York office, isn't able to join us tonight, so I'll do my best to capture his sentiments on our work as well as his partnership with Shigeru Ban. I'd like to begin by thanking Carol for including SBA in the Skyscraper Museum's Tall Timber Lecture Series, building on their fantastic current exhibition, and I highly encourage you to go visit it if you haven't yet. So in today's lecture, we'll start by discussing Shigeru Ban's trajectory from paper to wood, take a closer look at a few selected projects, and then conclude with some of our current work. So for a bit of background, Shigeru was born in Tokyo, Japan, and traveled to the US for his architectural studies at SCIARC and then the Cooper Union, where he met Dean Maltz nearly 45 years ago. And as Carol mentioned, Shigeru will be presenting a lecture on balancing architectural works and social contributions at Cooper Union next week for the 40th anniversary of their graduation. Shortly after graduating from Cooper, Shigeru returned to Japan and established his eponymous firm. And today we're a global practice with offices in Tokyo, Paris, and New York, and over 165 built works worldwide. In 1985, Shigeru's first professional project was an exhibition of Emilio Ambaza's work. And in the process, he was intrigued by paper tubes that he found at the center of rolls of fabric and fax paper. So noting that these tubes were strong, lightweight, inexpensive, and recyclable, he held on to them for future use. Later that year, he was commissioned to design an exhibition for Alvar Aalto's work. He had initially hoped to use wood as a nod to the Vipuri Library ceiling, but given the cost and waste associated with temporary exhibitions, he opted for paper tubes instead. A decade later, in 1995, Shigeru designed his weekend home, which is known as the Paper House. This is the first building in the world that was permitted to use paper tubes as primary structure. Shigeru often jokes with the office that he hasn't actually seen it since it was built because he's just too busy. This might be more of the paper tube work that this audience is familiar with. Shigeru is very well known for his humanitarian work. So he uses paper tube structures to create disaster relief shelters around the world. These are 4 instances of the paper log house, which is adapted to the local climate, culture, and construction practices of each site. Jumping ahead, this timeline displays Shigeru's progression from inventing with paper tubes at the outset of his career to the complex mass timber structures that we're familiar with today. But there isn't actually a distinct change from a paper era to a wood era because his timber innovation dates back to the 90s and continues in parallel with the paper works. It's important to note that Shigeru's work is not limited to one material. We as an office are not timber purists, so we build with paper and wood, but also concrete and steel, often in combination. Regardless of the material, the breadth of our work demonstrates that structure and materiality are integral to the design process and not merely the means of executing a predetermined concept. Shigeru's work in paper is chronicled in the book on the left, Paper in Architecture, which was published in 2009. And in 2022, we published the compendium to this book, Timber in Architecture. This new book was created both to show the breadth of Shigeru's work in wood, but also to serve as a primer on how to design with wood. Much like a building, a book is not a solitary endeavor. So I'd like to pause and acknowledge the global and interdisciplinary effort it took to make this book. We had contributions from across our Tokyo, New York, and Paris offices, as well as input from structural engineers, fabricators, and the editing and production team at Rizzoli. On behalf of myself and project editor Vittorio Lovato, I'd like to thank Shigeru Ban, Dean Maltz, and structural engineer Greg Kingsley for their immense input and guidance throughout this endeavor. So now let's take a look at the actual book. We begin with 3 guest essays to contextualize the importance of the subject of timber in architecture. There's a foreword by environmentalist and entrepreneur Paul Hawken, Shigeru's own essay, which is titled Why I Love Wooden Architecture, and Hermann Blumer's recounting of his career trajectory from carpenter to timber engineer. The body of the book presents 45 works from concept through to the completion of construction, demonstrating the merits and challenges of working with wood. These projects range in scale, budget, and program, from prefabricated plywood houses to parametrically modeled glulam gridshells, showing the spectrum of what wood can do. Projects are arranged thematically rather than chronologically. So here you can see clusters by structural typology. Each project is illustrated through photographs, technical drawings, and documentation of the construction process. The subject of timber and architecture is inherently interdisciplinary, so throughout the book, you'll read about great collaborations among architects, engineers, fabricators, and builders. The book concludes with an index of all of Shigeru Ban Architects' unbuilt, built, and in-progress timber projects. We have over 75 built timber projects around the world, from private houses to multi-building campuses. We'll be looking at just 10 of these tonight. But first, we have to ask, why wood? This is a question that we've been asked nearly every time we've presented for the past decade, and it was the impetus for this book. Wood is a versatile natural material with diverse structural possibilities. It's sustainable and renewable and can often be locally sourced. With offsite fabrication, timber construction sites are typically cleaner and safer, and construction schedules are often much shorter. You may be familiar with the term biophilia. Buildings with visible natural materials are noted for their positive psychological effects, promoting health, happiness, and even productivity. Part of our tasks as architects is to continuously learn and educate. And so now more than ever, it's imperative that architects, builders, clients, and even the general public recognize how construction impacts the environment. Issues of waste, permanence, and material selection are crucial considerations in a holistically sustainable approach to design and construction. You've probably all heard the statistics. Buildings account for nearly 40% of the world's carbon emissions, with 11% due to construction alone. But in terms of embodied carbon, wood far outperforms alternative structural materials such as steel and concrete. And this is a large reason why we advocate for timber. But it's reasonable to understand concerns. First, what about deforestation? Contrary to popular misconceptions, the use of sustainably sourced wood from small diameter trees promotes the health of forests and makes them more resilient and fire tolerant. Next, isn't it expensive? Many people think only about the unit cost of a material, but reductions in on-site labor and construction duration often yield considerable savings for timber projects. Is it safe? Won't it burn? Fortunately, sufficiently thick wood burns at a slow and predictable rate. So like any structural material, factors of safety are also required. The bottom left, you can see the results of fire testing. Oversizing the structure allows for a sacrificial outer layer that can char without compromising the structural integrity of the member. This charring acts as a protective layer, slowing the rate of combustion and insulating the core of wood. Finally, will it last? Coincidentally, the oldest timber structure in the world is in Japan. This is the Horyuji Temple, which is more than 1,300 years old. It still stands today in part due to its strong and durable materials, robust structure, precise detailing and construction, and also because it's of great cultural significance. As Shigeru often notes, if a building is loved, it becomes permanent, and this concept transcends materiality. Buildings that are meaningful to their communities are cared for, and that's truly the most environmentally responsible approach to create architecture that endures for generations. There are many arguments for building with wood, but why specifically does Shigeru Ban do this? Shigeru acknowledges the limitations of wood, and that's precisely what intrigues him. So whereas steel and concrete can easily take on any number of forms, you really need to understand the material properties of wood to optimize its structural form. By leaving timber unencapsulated, Shigeru allows the material to serve as both structure and finish, and this is a materially authentic approach that expresses the beauty and efficiency of rational structural forms. To do this, we need to collaborate. From the outset, we engage a team of structural engineers, fabricators, and builders, seeing real-world constraints as opportunities for innovation. Shigeru has great respect for his collaborators, and his introductory essay in the book is dedicated to his close working relationship with these three renowned structural engineers. Gengo Mitsui helped Shigeru's early paper tube concepts come to fruition, advancing beyond simple upright columns. With Frei Otto, Shigeru delved into form finding. So here you can see the influence of Otto's Mannheim multi-hall on Shigeru's paper tube pavilion in Japan. And lastly, we have Hermann Blumer, who also wrote an essay for the book. He began his career as a carpenter before pursuing a PhD in structural engineering in 1969. His focus on wood was actually looked down on at the time, since his colleagues didn't think wood was a complex enough subject. But Hermans persisted, and he became a pioneer of digital fabrication. He later designed the first fully automated CNC machine. You can see the breadth of his understanding of structure, materiality, and craft here in the Nine Bridges Golf Clubhouse. Next, we'll begin a deep dive into a selection of projects, beginning with the first project in our book, Furniture House 1. Sometimes the topic of local materials is less related to regional wood species and more a matter of what building materials are locally available. The first in an ongoing series, Furniture House 1 uses prefabricated plywood furniture units as the primary building structure. This residence is located on a remote wooded hillside, which posed construction challenges regarding site access. Standardized furniture units allowed for off-site construction, which reduced construction time, material waste, and the need for on-site labor. This yielded both cost savings and a higher quality building. The 33 prefabricated furniture units included closets, cabinets, and bookshelves. Each weighs approximately 175 pounds and could easily be maneuvered into place by just 2 people. The Bamboo Furniture House is the 4th house in this series. This one-story residence draws on traditional Chinese architecture, with rooms arranged around a central courtyard. Here again, Shigeru used furniture units, but as the name suggests, he selected a geographically and culturally appropriate material for their construction. Shigeru had found that local lumber options were limited near this mountainous site, but he was intrigued by plywood-like boards that he found that were made of laminated woven bamboo strips. He thought that this could be manufactured as a building-grade material, so he began to pursue rigorous testing with assistance from a bamboo factory. His newly developed material, which he deemed laminated bamboo lumber, or LBL, was used throughout this home for both bamboo furniture units, furnishings, and finishes throughout. This project epitomizes how Shigeru explores new and creative ways to address design constraints with local, natural materials. Increasing in scale, let's discuss what we do when code prohibits mass timber structures. Ironically, Shigeru has found that Japan has some of the most restrictive building codes in the world. In most urban conditions there, it is not possible to build in mass timber. The misconception in this case is that mass timber buildings are not safe, but in actuality, building code is not caught up to the realities demonstrated by rigorous testing. In the US, we're lucky to see code changes quite regularly. Shigeru grappled with this over 2 decades ago when he was commissioned to design a new office and showroom for a dental company. Since a timber structure was not allowed, he opted to work with steel for its strength and ability to span long distances. Steel requires a fireproofing layer, known as encapsulation, to prevent structural damage in case of fire. This is typically clad with a finish-grade material to improve its appearance. Subverting the logic, Shigeru demonstrated to officials that wood could in fact be used to fireproof steel. Fire resistance tests demonstrated that 50 millimeters, or about 2 inches of wood, adequately addressed the building's 1-hour fire rating requirement. Therefore, 2 layers of particle board with a plywood finish were used to encapsulate the steel. So despite not being a timber structure, the building retains the warm aesthetic of wood. Tamatic Nagoya is a more recent example. This aerospace and automotive engineering company wanted an innovative building that would take advantage of biophilia. And as I mentioned earlier, timber environments have been shown to improve employees' sense of health and well-being and even productivity. This 8-story building is also located in a Japanese city. So to satisfy the building code while retaining the warm aesthetic of wood, a hybrid approach was used here. Tamatic Nagoya employs CLT, which is cross-laminated timber, as the permanent formwork for the concrete floor slabs as well as the concrete column structure. On the right, you can see that a box was made of wood, filled with concrete, and then the wood was left in place. The use of permanent formwork has many benefits, most notably the biophilic benefits of wood, a shortened construction schedule, reduced carbon footprint by eliminating sacrificial formwork, and lastly, not needing additional finish layers because the wood serves as a finish. Increasing in scale, let's talk about mass timber itself. So in contrast to solid wood, mass timber is an engineered wood product that's composed of small diameter trees bound together, lumber from small diameter trees that's bound together by adhesives, nails, or dowels to create larger structural members. This has two primary advantages. First, it doesn't require the use of old growth trees. And second, mass timber is inherently stronger than comparably sized wood. Because it's a composite, mass timber is a standardized product with predictable strength characteristics. Common examples that you can see on the right side of the screen are cross-laminated timber, or CLT, glulam, as well as DLT, NLT, mass plywood panels, and many more products that are currently under development. Before we dive into the mass timber products themselves, or projects themselves, let's do a quick review of 10 key considerations to keep in mind when approaching a mass timber design. These points are applicable regardless of the complexity of the project. So first we have to stop and ask, why wood? Is it even the right material for the job? Oftentimes, a hybrid solution is the best approach. Next, we review the code to understand what you can do in a given jurisdiction and establish the building type and fire rating. From here, we can establish the structural grid, considering spans and member sizing in relation to vibration and deflection. Once the grid is established, we consider the MEP strategy. Do building systems bypass the structure or pass right through it? And lastly, how do we optimize the volume of wood to both minimize material waste and erection time? Now we can think ahead to constructability. Ideally, you want to meet with a potential mass timber supplier and fabricator at the outset of your project to allow them to influence the design process. So you can stop and think, what species of wood will you use? Is it native? In the US, in the Pacific Northwest, you might be thinking of a spruce pine fir, but in the South, perhaps southern yellow pine. You'll consider also the manufacturers' and fabricators' geographic proximity to each other, as well as your site. As you consider connections and tolerances, think about your partner's fabrication equipment and how the design will come together. With all of this in mind, you can allow your partner's capabilities and limitations to inform the design process. You simply can't fabricate projects in the same way in New York as Switzerland, for example, but you could leverage these differences to find opportunities. Lastly, begin to outline the erection strategy. This is something that we often do in schematic design at Shigeru Ban Architects. So from how many truckloads it takes to how you'll stage the site, this impacts both cost and schedule. We'll spend the remainder of the presentation looking at three structural typologies. First, post and beam structures, then space frames, and lastly, grid shells. Switzerland is a global leader in timber construction. The Tamedia headquarters is our office's first building in that country, and also the home of our friend Hermann Blumer, who is the structural engineer for this project. Tamedia is the largest media company in Switzerland, and they've occupied the same riverfront site in Zurich since 1902. With this new project, the client had three primary goals. First, to create a workplace that feels like a living room. Next, to make the building feel transparent, both literally and metaphorically as a media company. And lastly, to maintain a reasonable budget. In response, Shigeru designed a timber post and beam structure wrapped in a glass curtain wall. Switzerland has high energy performance requirements, so sustainability was a key factor. For example, there's an occupiable double facade, which you can see in the image on the right, and this acts as a thermal buffer while allowing for natural ventilation. Here you can see the retractable glass shutter is raised, creating a pleasant indoor-outdoor balcony. But how did we get to the finished building? On the left, you can see Shigeru's initial concept sketch as compared to the building under construction. They're so similar because Shigeru's design work begins with a structural idea. The timber structure was precision milled using Swiss CNC machines, the first of which was designed by Hermann Blumer. The robust columns and beams arrived on site like a kit of parts. Remarkably, each column was delivered as a single continuous piece, measuring 70 feet in length and weighing 2.5 tons each. This significantly reduced the construction time, which was a major advantage on a hectic urban site. The glulam columns and beams interlock at innovative joints, which are secured by an elliptical dowel without any metal connections. The form is both functional and elegant. The elliptical shape prevents rotation within the aperture. Hermann Blumer identified that the stresses were too large for spruce beams alone. Spruce is a softwood. So Hermann suggested the inclusion of concealed reinforcement plates made of beech, which is a hardwood. In the diagram and construction photo, you can see that the beech is the darker material. The design and engineering of this joint is one of many great examples of the collaboration between Shigeru and Hermann. Now we'll look at space frames, which are akin to 3D trusses. This is the Aspen Art Museum, which recently celebrated its 10th anniversary. The Aspen Art Museum was designed to be a unique yet contextual building, so its woven wood and paper composite facade is evocative of the color and rhythm of Aspen's historic brick buildings. The porous screen facilitates views into the museum as well as out towards the mountains. Here you can see two views of the Grand Stair, which is an indoor-outdoor interstitial space behind the woven screen. Similar to the experience of skiing, the museum was designed to be circulated from the top down. Visitors first ascend via the Grand Stair or a glass elevator, and then arrive at the rooftop plaza before descending to the galleries below. Shigeru believes that the natural context is as beautiful as the art, so it was important to highlight the stunning views of nature with the only free public rooftop in Aspen. The timber space frame structure extends from the outdoor rooftop plaza to an indoor cafe. Below, the building interior is arranged according to what we call the thermos principle. Climate-sensitive galleries are concentrated at the heart of the building and are surrounded by less climate-sensitive spaces such as lobbies, hallways, elevators, and offices. This minimizes the temperature and humidity fluctuations in the galleries and allows the perimeter zones to take advantage of visual and physical connections to the outdoors. In the left two images, you can see Shigeru's hallmark paper tube furnishings and finishes. This humble material even has a place in a museum. So now let's take a closer look at the timber roof structure. For comparison, on the left, we have Shigeru's initial concept sketch, and on the right, the digital model, which was used for fabrication. Here, too, the project began with a structural and material concept. For those familiar with space frames, you may notice that the roof structure is not a typical space frame. The webs are curved, which allows for sufficient wood-to-wood contact so that the webs can be connected directly to the cords with just diagonally oriented wood screws. As a result, there are no exposed metal connections. The structure was developed in conjunction with Hermann Blumer of Creation Holtz, Greg Kingsley of KLNA, and Fabricator Erector's Spearhead. Here in the upper left, you can see the 2D webs in Spearhead's shop. The timber components were fabricated and shipped to the site in the longest possible transportable lengths, which ultimately minimized on-site labor and construction duration. Now moving on to gridshells. The Centre Pompidou Metz is perhaps Shigeru's most iconic building and one of the most well-known mass timber structures in the world. And though it's hard for us to imagine today, the client initially suggested switching to a steel structure. In 2003, the Centre Pompidou hosted a competition to design a new museum outside of Paris. The intent was to show more of their 120,000 works from their collections, as well as larger works that wouldn't fit in the Centre Pompidou's 18-foot ceilings. Given the architectural significance of the original museum, Shigeru saw the opportunity to build an unprecedented structure. The museum was designed as an open pavilion in a park. Unlike its peer institutions, the Centre Pompidou Metz is not a walled-off institution. Here you can see the 16-foot tall glass shutters retract to connect the building to the surrounding landscape and park. The building consists of a timber grid shell suspended from a 250-foot tall steel core tower. Despite its sculptural image, the roof defines a simple hexagon in plan, which is symbolic of the shape of France. 3 gallery tubes below are oriented towards local landmarks. So here in the upper right, you can see one of the gallery tubes, which is 300 feet long, is oriented towards the 16th century Gothic Cathedral of Metz. For the iconic roof, Shigeru drew inspiration from 2 seemingly unrelated sources. The first, cable net roofs designed by Frei Otto, which have a separate cable structure and wood enclosure. And the second, the self-supported woven structure of traditional Chinese hats, which made Shigeru question the necessity of cable net structures. In a typical triangulated joint, you'd have 6 members intersecting at a point. This yields a very complex and expensive joint. But here instead, you can see the influence of the woven Chinese hat. By offsetting the grid, only 4 members meet at a single point. This is the ingenuity of Metz. The story of this building's structural resolution is really quite fantastic. After the initial team of engineers proposed a hybrid structure followed by a solid wood structure that was twice the roof's budget, the client asked Shigeru to change the roof to steel. But Shigeru wasn't deterred, so he went to Germany to consult timber engineers and builders. At the airport, he was greeted by a Swiss man who he thought was a taxi driver, but it was in fact Hermann Blumer. The 2 sides of this story are beautifully recounted in the 2 introductory essays of the book. Shigeru described his conundrum, and Hermann cheerfully responded that he would have a solution and a cost estimate within 2 weeks. Truthfully, he had no idea. Then, and every time since, when Shigeru gives him a complex problem, Hermann goes off to the Swiss mountains to think and always comes up with a brilliant solution. Independently, Shigeru and Hermann each realized that they should not only simplify the grid in 2 dimensions, they also had to offset the depth of converging members so that they would bypass one another at nodes rather than intersecting. They could then be connected by a simple pin. In this configuration, each beam is a simple Vierendeel truss. Similar to Tamedia, the beams are made of spruce, a softwood, and connections are made of beech, a hardwood, which takes on the high stresses of the joint. The double curvature of the roof takes advantage of digital fabrication processes that Hermann Blumer pioneered. This project predates our other mass timber buildings and was the catalyst for Shigeru's innovative work in mass timber, as well as the start of his collaboration with Hermann Blumer. The last built project that we'll look at this evening is the Swatch Omega campus. At over 500,000 square feet, it's among the largest mass timber building projects in the world. The campus integrates 3 new mass timber buildings into a historic watchmaking campus in Biel-Bienne, Switzerland. On the left, you can see the Omega factory. On the right, the Swatch headquarters. And between the 2 is Cité du Temps, which is the Swatch Omega Museum. The buildings share a design language reflecting the unified brands of Swatch and Omega, while expressing each building's individuality through contrasting structural forms. We'll take a quick look at the 2 rectilinear buildings, but focus on the grid shell. The Omega factory was built first. The Omega brand is known as the timekeeper for NASA as well as the Olympics, so it was only fitting to have a clean rectilinear form that reflects exacting Swiss standards. The building is a post and beam structure with a rigid concrete core, flanked by timber-framed watchmaking workshops. Working conditions were a primary factor in the building's design. Most notably, literal cleanliness is highly important here. The Omega factory is the first building in the world to achieve clean room standards. This certification is important for the sake of craftsmanship as well as employee health. The workspace must be evenly lit and dust-free with minimal vibrations. Since mass timber is known to vibrate, a concrete topping slab was added to increase the weight of the CLT structure. In contrast to the maturity of Omega, the Swatch brand is playful, innovative, and provocative. Though the serpentine form and facade design appear unrestrained, each is responsive to a practical design constraint, ranging from code and zoning setbacks to material properties and building services. The structural grid shell covers 4 office floors, connected via 3 concrete cores. The timber structure is composed of a 7-foot grid of interlocking timber beams that seamlessly transition from wall to roof structure, and the office space below is open and flexible, fostering collaboration. The Swatch headquarters was designed in a truly contemporary manner without traditional construction documents. Instead, a parametric digital model accounted for the specification of all 7,700 timber components with a precision of 0.1 millimeters. This allowed the wood to fit together perfectly on site like puzzle pieces. In a more typical building project, you might expect errors to impact up to 15% of the parts delivered to the site. But this complex grid shell had only a 0.11% error rate, meaning that only 72 of the 62,792 prefabricated roof elements had an error. This is a testament to the truly interdisciplinary and collaborative nature of the design process. SBA worked extensively with structural engineer Hermann Blumer and his firm Creation Holtz, as well as digital facilitators Design to Production, who created the digital fabrication model and resolved conflicts that could have arisen in the integration of building services. This dynamic team has worked together for nearly 2 decades, beginning with the Centre Pompidou Metz. The building envelope integrates structure, building services, and the facade. Here you can see structure in yellow, services in green, and the facade in blue. Since the maximum footprint of the building was fixed due to site constraints, an unnecessarily thick envelope would have reduced the building's usable floor area. To resolve this, Shigeru drew inspiration from the original Swatch watch, which integrated components directly into a manufactured plastic case. This reduced both the cost and the thickness of the watch. Shigeru's approach was similar. Instead of discrete layers of structure, building services, and facade, he integrated the 3. The facade nests into the structure, and the building services pass through it. Prefabricated openings were tailor-made to the size of electrical cables, sprinkler pipes, and cooling pipes, with cutouts staggered and mindful of the wood grain so that the structure would not be weakened. The 120,000 square foot roof surface has 2,800 apertures arranged in a spirited pattern. ETFE cushions, which are white and pillow-like, are employed for diffuse daylighting, which helps to create a glare-free environment for the office. CLT panels at the high points of the roof reduce the solar heat gain. PV panels on the top and south side of the building offset the building's energy consumption. And the Swiss cross form acts as structural bracing and acoustical absorption. At the lower levels, glazed panels provide views of the neighboring park. The Swatch gridshell reaches over the festival street and sits atop Cité du Temps. This museum and conference center acts as the interface between the 2 brands. So you can see that the museum incorporates the architectural language of its 2 neighboring buildings, with playful concrete arches at the base, a rectilinear timber structure for the 2nd through 5th floors, and a mansard roof evocative of the campus's historic buildings. The Omega factory has a concrete core and topping slab, but Cité du Temps is an entirely timber structure above the ground floor, with glulam columns and beams and CLT floor slabs and core panels. This is an outwardly simple building, but its complex interfaces required great attention to detail. Not only are there timber and concrete structural systems, but the building literally intersects with neighboring buildings on both sides. Despite being such an enormous project, collectively, these 3 buildings were constructed from 160,000 cubic feet of certified Swiss timber. Considering the growth rate of Swiss forests, it would only take 10 hours to regrow this quantity of wood domestically. That's 0.1% of Switzerland's annual timber production. Now we'll take a look at one of our current projects from the New York office. Kentucky Owl Park is a 500,000 square foot distillery in Bardstown, Kentucky, sited in a 420-acre reclaimed limestone quarry. The distillery is on a peninsula at the center of the site, surrounded by production buildings, including a bottling center, craft cooperage, rick houses, as well as visitor center and train station. Here you can see 3 pyramids of the distillery. The adjacent lake water will be used to make the bourbon. In the first pyramid, visitors gather for tours and are educated about the bourbon making process. The second pyramid, which is shown at the right, is where distillation takes place. The shape of the pyramid actually comes from Shigeru's pragmatic idea to efficiently accommodate the 60-foot tall column stills at the center of the building while minimizing the overall volume of the building. And in the last pyramid, the bourbon is placed into barrels in preparation for aging. The roof structure here may appear familiar. It's actually an evolution of the Aspen Art Museum's wooden space frame. In the visitor center, we drew inspiration from the structure of a bourbon barrel. The dendriform columns are a combination of timber and steel, which is evocative of wood staves and steel hoops from a bourbon barrel. We'll conclude with an animation of the project. appear to have lost my video for the end here, but just to conclude, we're looking forward to adding Kentucky Owl Park to our grid of completed projects. We can learn so much from discussing the trajectory of a project from construction through to from concept through to the completion of construction. And so this evening, we only took a look at 1/4 of the projects detailed in timber and architecture, skipping over structural typologies such as arches, domes, and tree columns due to time. Prior to the publication of this book, Shigeru Ban was the only person who knew all of these details. So I hope that you understood a few key points. I hope these points resonated in this talk. First, that across the spectrum, from simple plywood houses to complex grid shells, wood presents a great breadth of possibilities in the face of constraints. And second, appropriate material selection and application is a critical factor in our efforts to build responsibly and reduce carbon emissions. That doesn't mean that wood is always the answer or that more wood is inherently better. And lastly, this is a highly collaborative field. Architects don't work in isolation, and the relationships we build with engineers, fabricators, and builders carry on from one project to the next, evolving a collective body of work. This book was also a collaboration, and the best way to advance the discipline of mass timber is to share our respective knowledge and experience. So with that, I'd like to say thank you again to Carol Willis and the Skyscraper Museum for facilitating the Tall Timber Talks this summer.
Well, thank you so much, Lauren. I don't know if you want to try to see if you can, there you are, come back on the screen. Well, maybe as long as we haven't lost you completely, maybe we can have a little bit of a chat in our last remaining minutes. The work is so beautiful and really very inspiring. You know, thank you for that. You made it very clear that the depth of feeling and collaboration that exists within the aesthetic in the firm. I wonder, let me invite people to ask some questions in the chat if they would like to, because we do have a couple of minutes that we can still spend. But let me ask you to talk or tell us a little bit more about how the offices work in the three capitals. Tokyo being the home base, but in Paris, it's mostly the European projects, and now that we've seen an example of some of the U.S. or North American. Can you talk just a little bit about how the office operates, how they generate the projects and the work?
Sure. So the office was founded in Tokyo in 1985, and from there, satellite office opened in Paris with the start of the Centre Pompidou Metz project. And interestingly, Shigeru didn't have the budget to open an office in Paris physically, so he asked if he could create a paper tube structure on the roof of the Centre Pompidou to house his staff. And that was the start of our Paris office. And he would joke anytime a client wanted to come visit him, they'd have to buy a museum ticket to go up to the rooftop. We've since moved into a more permanent office in Paris. And then the New York office began with some early collaborations between Dean, Maltz, and Shigeru in the early 2000s, first with the MoMA paper arch. And then a few years after that, that was 2001. And a few years later, they began a formal partnership as Shigeru began to pursue more work in North America. So today we tend to be a little bit geographically siloed, that New York addresses projects in North and South America. The Tokyo office addresses projects in Asia and Australia, and the Europe office does, our Paris office does Europe, the Middle East, and Africa. But as the world has changed over the past few years since the pandemic, we do tend to collaborate across offices much more. And so you'll see in the middle of a competition, it's actually like people are working 24 hours because you go to bed and your colleagues in Tokyo just keep going.
So you've mentioned competition, certainly in terms of the Pompidou Metz. I mean, that was really a breakthrough project in many ways. The office still competes in competitions. I know some countries require that, and then there's the convention of competition. So do you eagerly embrace the competitive process?
It's a double-edged sword. Competitions are a wonderful opportunity to try new ideas, and usually clients who host competitions are interested in innovation and not just seeing a cookie cutter building. But as everyone knows, they're intensive periods. So we do tend to compete for cultural projects. Most museums, performing arts centers, even the Kentucky Owl Bourbon project, all require competitions, some design competitions, others not. We also, it's great that we won the Kentucky project. There are a number of near misses that we've had in recent years. I would encourage you to look them up as well. George Brown College, we'd had a great timber structure, again, working with the same collaborators that you've seen throughout this presentation. University of Arkansas also hosted a wonderful competition a few years ago for their architecture school. So with the idea of promoting timber in architecture. So it is actually really nice when a client comes to us for an invited competition, has the idea of wanting to work with wood, and we don't have to start with a preamble of like, here's why it's okay to build with wood. Here's why your building won't burn down.
And one of the messages and initiatives of the exhibition of tall timber and the future of cities and wood is to make the point that the material is very conducive to multi-story housing. Of course, housing, and especially workforce housing, of which there's some examples in the exhibition, seems to be a kind of perfect range in height for the engineering capabilities of mass timber, and also somewhere kind of halfway in between the aesthetic, the humanitarian aesthetic, and the kind of multiplication of inexpensive forms to answer human need. And the kind of aesthetic expression that one finds in the more institutional projects. So in that middle ground, is that an area that the office is exploring?
Yes, and if you happen to know developers who are looking for an architect to explore that area, we are very interested in that. It is hard when you, from a humanitarian perspective or cultural or a conceptual perspective, want to work on a project like that, to find a good marriage of intent and project and budget. We would love to be working on more projects in that range, and we're actively pursuing workforce housing as well as public education types of buildings to concentrate on rapid, repeatable construction to create these beautiful spaces, to say that architecture doesn't have to be expensive in order to be a wonderful place to live, to learn, to work.
Mm-hmm.
So stay tuned. There are some projects in the pipeline that would address this.
Mm-hmm. And well, related to that, I know one of the points that Shigeru makes in lectures that he often gives is economy, not just an economy of structure, but actually thinking of ways in order to solve the problem of finding the least cost solution, whether it's for a high-end project or the disaster relief. Can you talk about how that figures into the strategies and the philosophy of the firm?
Shigeru is really wonderful because his design intent pervades all aspects of his personality, how he approaches projects. He doesn't want to do a timber project for its own sake, or a vanity project just to build something expensive. So recently we had a client approach us and ask us to design a mass timber structure. And Shigeru looked at the brief and the size and the program and said, there is no need for this to be a mass timber structure. It can still be a timber structure, but why would you use that volume of material for just a single story building? And so we're in the process of developing a timber box beam instead, which would be much less expensive, much easier to construct, wouldn't require highly skilled labor. And so I think to that point, Shigeru always tries to select the material and the approach that's commensurate with the design need.
Mm-hmm. And that relates to something, a question that I had as you were showing the slides, the hardware that's in combination with the timber members. You showed the innovations like that, the hybrid beam or column, I guess. Do you work with other companies in order to spec a kind of invention of a new hardware, or how does it fit into the industry, the existing industry?
I think it really depends on whether it is a project that is designed to be mass deployed to use readily available materials, fasteners, et cetera, or if it's something bespoke with all custom concealed joints, for example. I think you might have been referring to the dendriform columns of Kentucky Owl, where we'll have the steel hoops in combination. Well, they're hoops evocative of a barrel. That's something that we're currently developing. So for projects like Media, where you have the integration of hardwoods and softwoods at a joint, or other projects where we're trying to conceal the hardware, that's something we're very early in the process. We're talking with our structural engineers and fabricators to actually resolve those issues, to make full-scale mock-ups and test how it actually works, rather than designing something beautiful in a rendering and then going to construct it, and then you see more joints than you expect.
Mm-hmm. Well, we're almost at the end of our time, and this has been really a feast of information and visual display. You've clearly communicated the inventive and creative aesthetic and also engineering approaches that Shigeru Ban Architects examples in their work. Certainly one of the great architects of our era, and someone who is both an originator and someone who works deeply in the nature of materials. So this has been a really terrific addition to the series of architects and engineers who've spoken about their work in timber. And I would direct everybody to our website where the videos are archived. So you can see other architects like Michael Green and Thomas Robinson and Susan Jones and others talking about their kinds of invention within the kind of emerging tradition of mass timber. So this is a very kind of culminating work in order to see the spectrum of the experiments and applications in Shigeru Ban's work. So we thank you for putting the book together and for putting this talk together, and delighting us and treating us to it tonight. So thank you so much, and everybody do come back for an exploration of concrete and engineering, where we'll continue our material studies. Come back this Thursday and go to our website so that you can, or our YouTube channel, where you can find these all in series, and do come back for the book talks that we have scheduled for the fall, because we have a kind of Asian focus. And our next talk, which is in early October, on cities of repetition, by a Hong Kong-based architect teaching at the university and now in Sharjah in the Middle East, speaking about Hong Kong housing as a type. So that is something that we'll explore, not in wood. And then another book talk in November on Chinese architecture, 180 years of tradition. So we have a kind of Asian focus in our authors talks for this season. And we're really delighted to have kicked off our fall season with this incredible, beautiful work by Shigeru Ban Architects. So thanks, Laura. And I hope I'll see all of you there back again this week and through the fall. So thanks again, and see you next time.
Thank you, Carol.
Thanks.